To ensure that Pakistani enterprises have access to cost-effective large gears, small workshops utilize traditional sand casting methods. Although this method is relatively slow, it, combined with simple mechanical equipment, can produce precisely structured large gears. Given the massive size of the gears, traditional sandboxes can no longer suffice. Therefore, the craftsmen dig a huge circular pit in the ground to serve as the casting sandbox. After digging the pit, they lay a layer of highly cohesive and plastic molding sand at the bottom. This molding sand is ideal for making large workpiece molds. Experienced craftsmen use a square tube and a level to create a level base. Once the sand is laid, they poke numerous small holes in the bottom and inject carbon dioxide, which quickly hardens the sand into a solid base. After the base hardens, the craftsmen place a sun-shaped gear mold in the center of the casting pit and cover it with the top layer of the gear mold. This completes the initial formation of the gear's main model. Next, they start manually creating the gear teeth. This process is relatively simple, requiring only that the craftsmen fill the mold with molding sand, compact and smooth it, and then inject carbon dioxide to harden the sand, forming an accurate gear teeth mold. The gear teeth are precisely placed in the positioning device, with the slots on the device matching perfectly with the gear teeth molds. This ensures the accurate positioning of the gear teeth models. Casting the entire giant gear requires 16 gear teeth models, which poses a significant challenge to the workers' backs. Once the gear teeth molds are placed on the base, the craftsmen use molding sand to fill in the gaps, ensuring the mold is completely sealed inside. Next, they backfill the casting pit with the surrounding sand, which both supports and secures the gear model. To further enhance the mold's stability, the craftsmen compact and tamp the surrounding fill. They then lay another layer of molding sand on top, shaping it into a square platform. The craftsmen use an iron frame to support the upper mold and reserve vents and pouring spouts with red bricks. The vents effectively expel the high-temperature gases produced during casting, reducing the risk of mold cracking. To ensure the stability of the upper mold, they also add rebar inside to prevent the upper mold from cracking under the pressure of the molten iron. Afterward, the craftsmen compact the molding sand inside the iron frame to ensure the upper mold's solidity. After shaping the upper mold, the craftsmen use a crane to lift the model out of the casting pit and remove the wooden boards from the gear mold, leaving the basic shape of the gear. Then, they lift a cylindrical sand mold and accurately place it in the center of the gear model to create the gear's axle hole. Next, they use the crane to bring the upper mold back together and fill all gaps with molding sand to prevent molten iron from leaking out. They also place heavy weights on top for added pressure to prevent the mold from shifting during casting. With these preparations complete, the large casting mold is fully ready, and they can now await the pouring of the molten iron. Meanwhile, on the other side of the workshop, craftsmen are selecting metal materials for melting. These materials mainly come from old machinery, scrapped vehicles, and other metal waste. They feed the scrap into a large medium-frequency induction furnace for heating and melting. During this process, the craftsmen must react quickly to avoid any dangerous situations. The high-efficiency heating of the induction furnace melts the scrap iron into molten iron within about 2 hours. Once the iron is melted, a hydraulic system lifts the furnace to pour out the initial molten iron containing impurities for preliminary cleaning. After removing all impurities, the clean molten iron is transferred to a large ladle, which must hold at least 3 tons of molten iron, highlighting the large scale of the gear being cast. When the ladle is filled with molten iron, it is transported to the gear casting mold location. The heated molten iron flows slowly into the mold through a chute, creating an intense and spectacular scene. The craftsmen carefully monitor the flow of molten iron in the sandbox to ensure it fills the entire mold evenly. After the molten iron completely fills the mold, the casting needs to cool naturally for 24 hours. This step is crucial to ensure the final gear's structural integrity and completeness. Once cooling is complete, the crane equipment is used to lift the formed gear out of the sandbox. Due to the tight adherence of the molding sand, especially in the deep grooves of the gear, cleaning these sand blocks becomes a challenge. Conventional steel needle cleaning methods are ineffective for the hard sand blocks, so high-powered electric picks must be used to break them apart. Through the skilled operations of the craftsman, all the sand on the surface of the gear is thoroughly removed, revealing a clean metal surface. At this stage, the gear has taken its initial shape but is not yet ready for direct use because it still has the casting gates formed during the pouring process. The next step involves using acetylene for precise cutting to achieve the final shape of the gear. Although the gear has been cast, it is still a rough blank at this stage. The next step involves machining this massive piece. The crane lifts the gear and slowly moves it into the workshop, where it is securely fixed on the lathe's chuck. Once everything is ready, the lathe is started, and the rough machining phase begins. The main goal of this phase is to quickly remove excess material to form the gear's general outline. The craftsmen use their extensive experience to control the lathe, making large cuts efficiently to roughly shape the gear. After completing the rough machining, the gear enters the more precise finishing stage. In this phase, each contact of the tool must be extremely precise, with significantly reduced cutting depth and slower, steadier speeds. This ensures that every detail meets the required precision for the gear's performance in actual use. Once the surface turning is complete, the next step is shaping the gear teeth. The craftsmen first apply marking paint on the gear's surface and then place a gear model over it, using a pen to outline the cutting positions. After the lines are drawn, the giant gear is carefully installed on the shaping machine, ensuring it is correctly fixed in the lathe chuck to prevent any errors due to vibration during the machining process. Once the lathe is started, the tool moves along the preset path on the gear's surface, gradually cutting out each tooth shape. This ensures the consistency and symmetry of all the teeth. As the tool cuts deeper into the gear material, the teeth gradually take shape. The craftsman must closely monitor the wear of the cutting tool to ensure the continuity of the entire machining process. After approximately 48 hours of continuous precision machining, the giant gear finally completes all the turning work. This entire process not only showcases the high skills and craftsmanship of Pakistani craftsmen but also reflects their ability to produce large mechanical components that meet strict industrial standards, even in resource-limited environments. This is truly impressive. Through these techniques and the diligent efforts of the craftsmen, we can see their professional level and innovative capabilities in the field of mechanical manufacturing. What are your thoughts on the skills and craftsmanship of these Pakistani craftsmen?